So that's 1,000 times 0.2 times pi. So 628.3 ohms. Okay, these are all the same units. They're in ohms. So you see the reactance of the inductor is comparable to the resistive reactance, okay? To the resistor. Xc is 1 over omega c. And C is 2 microfarads. All right, we'll bring that to the top. That becomes 10 to the 6, and this is 1,000, so 10 to the 3. So this is equal to 10 to the 3 divided by 2 pi ohms. So at this frequency, and so in most problems that you encounter, generally the R, XL, and XC will be in the same ballpark. So this is 500 ohms, this is 630 ohms, and this is 160 ohms. Okay. And so now we are ready to calculate Z. So Z is equal to R squared plus XL minus XC squared. So the impedance of the circuit is 685 ohms. Okay, and you can notice that this part changes with frequency, but this is independent of the frequency. So the impedance will always be greater than 500 ohms at all frequencies. Okay. There'll be a frequency at which it's minimum, which is 500 ohms, and that happens when this cancels that. Okay. Part B, what amplitude of the current, what is the amplitude of the current from the source? So now we can calculate the amplitude of the current. I max is V max divided by Z. And so they tell you the voltage amplitude is 100 volts. Okay, so they tell you V max. This is 100 volts divided by 60. And so that is the amplitude of the current at this particular frequency. Okay. So that's the current amplitude. And then they ask you, if the EMF of the source is given by this, how does the current vary with time? So now they're asking you to find phi. Okay. So they tell you The voltage is 100 volts. That's the amplitude. Sine omega is 1000 pi t. Okay. They're asking you what is the current. Okay. So essentially you want to find phi. Phi is tan inverse of XL minus XC over R. You found XL over XC. Okay. Okay, there's phi. Okay, so phi is that. We got to convert this to radians. Okay. So now the current is the amplitude of the current is this guy is V max over Z times sine omega t minus phi. Okay, so that's 0.146 amps sine 1000 pi t minus 0.7. Okay, so there is the current. Yeah, and then there's a repeat the calculation with C change, so you guys can do that. All right, so here's a AC source and a series RLC circuit. For the circuit shown below, what are the total impedance, the phase angle between the current and the EMF, and write an expression. Okay, so you want to calculate all those things again. Okay, so R is 5 ohms, R is 5 ohms, XL is omega L. What is omega? Hmm? Omega is 120 pi. Okay. So 6 point. All right, now that we have all the pieces to get all the pieces, so let's calculate the impedance of the circuit, which is 5 square plus 9.4 minus 6.63 square. So the impedance of this series RLC circuit is at this frequency. At that frequency is, and this frequency is 60 hertz, 2 pi f. So it's 60 hertz. Okay, so that's a signal coming out of the wall. And the amplitude is 170 ohms. Okay, 70 volts, 170 volts. So there's the Z, the phase angle. So this is part A. How do we find the phase angle? Tan inverse of XL minus XC divided by R. Tan inverse of 9.4 minus 6.63. (29 degrees). Okay, and then you can convert that to radians. So we have to convert this to radians. And the expression for Imax is Vmax over Z. So IT is 29.7 amps sine 120 pi t minus 0.5. Okay. That's the expression for I as a function of, and just I'll write this guy 170 volts sine 120 pi t. So there's the voltage and the current as functions of time in that circuit. All right. All right, we'll stop.